Hey everybody, Scott Wilkinson here. I'm at CEDIA Expo 2013 in the Seymour Screen Excellence booth, talking with none other than Chris Seymour himself about the new screen technologies here at the show. Chris, what can you tell us about it?
Well, what we're showing this week, Scott, is at the show is what we call our Visionaire ambient screen. And this uses a new technology to reject ambient light. And what we've done is we've taken nano mirrors that are 4 times smaller than what you could see. And so in the case of in the graphic, we're showing a 16K resolution pixel.
So in other words, each of these mirrors represents a 16K resolution?
No, actually in each 16K pixel, you would have over 300 of these mirrors, just
Wow.
to give you an idea of how small we're talking about.
Yeah.
So what that does is when the features to give you that gain and reflection back of the image are so small, you won't get sparklies, you can't get any uniformity issues and such. This is the most light-efficient technology for rejecting ambient light available. And the nano mirrors are stacked in a stack, so they actually have depth to them. And in between, like a Venetian blind, and in between those mirrors are light particles, or light-absorbing particles. So like little black
dots.
Yeah.
Nanodots.
Nanodots, sure. And what that does then, of course, is it absorbs the side light reflection, as well as then the substrate itself.
Now, are the orientation of these little tiny mirrors random, or are they?
They are dithered about at the angle that we choose to have the viewing angle for the screen. So in this case, we've got about on each side for a plus or minus 40 degree field of vision with this. This is our 2.0 material, so this will be the first material that's released. So we're going to start at the high gain and then work our way down and see how black can we get it.
Right.
Of course, but the advantage of starting with the highest light efficiency is that makes then the screen maker's job much more easy.
Well, true, because a high gain screen is going to focus the light back to the viewing area and less off to the sides to begin with.
And that's true. And if we have a more light efficient technology, we don't have to be quite as aggressive with those reflectors as you would if you combined a very low efficiency screen, for example.
Right. Well, that's fantastic, and we're seeing a demonstration here. Yep. This is
just a matte white, just a common 1.0 matte white screen. And so you can see in these show conditions, we've got about
which is pretty difficult.
It is very difficult. I remember previous years they had dimmed it down a little bit. But we're showing, we measured this morning a 5 times improvement in the contrast ratio with this, and it's just a consumer grade projector. It's nothing fancy. It's about a $2,000 projector.
Right.
So we're just showing that at the lower end of things that it's a watchable image, and we're even in show conditions, and we're able to achieve.
Yeah, fantastic. So when will this be available?
This will be available this fall, actually. So.
Now, I know it's difficult to price screens because it depends upon the size. Will this be retractable, by the way, and be available in a retractable version? Probably not, because of all these tiny little micro mirrors.
Next year, because
but you're thinking about doing it.
It'll be a completely different retractable than what we do. Currently, we make a velvet stitched, fabric bordered, almost like a tailored screen. But we have to. That's only good for woven materials. When we get into films like this, then we have to go with the more smooth rolling type techniques that we have to paint the borders, perhaps, or even in the darkest ones, maybe they don't need borders at all. So we'll have to get there when we get there. But that'll be a next year project.
Yeah. I'm assuming this will command a premium price.
It's an expensive technology. I mean, laying the mirrors down. I mean, each screen will have billions of mirrors on it. So it's an expensive technology, but we think we can be price competitive with everybody out there, and then we think we can show a performance advantage as well.
Boy, I thought DLP was amazing with their tiny little micro mirrors.
Ours don't move. Yeah, it's the moving part. Right, that's the magic, right?
Right, exactly. And the uniformity is good, I would think.
Absolutely.
Within the viewing cone.
Yep, absolutely. Because what we've done is when you dither those mirrors, then you've defined your viewing angle, and you've set those parameters. And so then you get excellent uniformity within that band.
Fantastic. And anything else at the show you're showing?
Also at the show, we're showing a couple of things. We have a new slim profile extrusion for our acoustically transparent screens, and of course we'll have our ambient, Visionaire ambient in that as well. But it shrinks the bezel down for multi-purpose environments, so you get down to about that half-inch wide viewing angle, which is from a projectionist perspective, I'm not sure I understand, but from a aesthetics,
from the designer's perspective, maybe it's okay.
I understand.
Yeah,
it's sleek and attractive. attractive.
Yeah.
So we have that, and then what we call in the J frame, which is another small extrusion. So we can have border sizes all the way from literally 0. We can do a frameless design, all the way up to our reference, which is a 3 3/4 inch wide, nice big, bold border for the
Fantastic.
for the projectionists out there.
Yes, indeed. Well, thanks so much for talking with us.
Thank you, Scott.